Hi, my name is Eileen Maxwell, and my thesis is titled A Relationship Between Wetland Water Level and Groundwater Flow Patterns, a case study in McLean County, Illinois, using temperature modeling. Illinois has 27 million acres devoted to agricultural land use. In order to reduce flooding in the fields, tile drains were installed to move large amounts of water into nearby open water sources. The tile drains act as a highway system, moving excess nutrients from fertilizers into surface waters, causing damaging effects on the ecosystem. A natural solution to reduce nutrient impact and maintain farm yields are wetlands. This research focused on understanding the physical characteristics of the wetland water level patterns and groundwater patterns using temperature tracer to improve the hydrological conceptual framework of the groundwater wetland system. The thesis involved multiple analysis in order to understand the hydrogeology of the study site. The project analyzed and compared regional flow models to local flow models, chemical tracer tests to natural tracer tests, and other hydrogeological variables influencing both groundwater and wetland patterns. A superficial geological map was produced using parent soil polygons in ArcGIS to create a 7.5-minute quadrangle of Colfax to better understand the geology of the wetland. The geology of the wetland is composed of glacial deposits which restrict groundwater movement at depth, causing local shallow groundwater to dominate. In general, the presence of water within the wetland alters the local groundwater flow direction. The underlying groundwater flow direction does not change, but the presence of water within the wetland creates an area of recharge from which water appears to radiate in all directions. For temperature modeling, the wetland temperature reflected both seasonal and daily temperatures, whereas groundwater temperature reflected only a seasonal signature. The groundwater temperature had a higher than the mean annual air temperature. This describes groundwater as shallow water influenced by the wetland and land surface temperatures. For future work, creating a 3D model in CWAT software, which uses temperature as a single species solute, will present advantages in calculating groundwater flux, velocity, and residence time to further the conceptual framework of the groundwater wetland system.